Good evening once again. My name is Arnold DeYoung and this is Mathemodium. Now this is a calculus lecture series, and in today's video I also want to hold a tutorial session for you students on limit. Now we've solved a lot of questions on limit, mostly on indeterminate forms of limit. We know by far we know three forms of indeterminate, that is 0 over 0, infinity over infinity, and infinity minus infinity. Now I want us to solve a few problems, then we move on to today's main work. Now, so the first problem I want us to try is the limit as x approaches pi over 4 of 1 minus sine 2x divided by 1 plus cosine 4x. Now, this looks a bit tough, but then it's not tough. It's not tough at all. So I'll do one thing. I'll try and expand cosine 4x. So I know, but then first we have to check if it's an indeterminate form of limit. So let us check. Doing our direct substitution, as x is approaching pi on 4, we get sine 1 minus sine 2 times pi on 4 gives us pi on 2. All on 1 plus cosine 4 times pi on 4 gives us pi. So now what are we going to get? We know sine pi on 2 is, that is 1. Then cosine pi is -1. So we end up with 0 over 0, meaning this is an indeterminate form of limit. Now, though we don't have an algebraic expression, or if I should say polynomial, in either the numerator or the denominator, we have a trig. But then for this particular trig, we can try to factorize the denominator, right? So that we can cancel out some of the factors in the numerator. That's what I will do. First, I want to expand cosine 4x. Now, you remember from trig that if you have cos A plus B, it is written as cosine A cosine B minus sine A sine B. We'll be using the same idea. So if you have cos 4x, this can be written as cosine 2x plus 2x is equal to cos squared 2x, because you have cosine 2x times cosine 2x, cos squared. So cos squared 2x minus sine squared 2x. So my cosine 4x is equal to cos squared 2x minus sine squared 2x. Now, there's also one thing I can do. You see, I want to make cos 4x the subject, such that all my terms will be in sine, so that when substituted into the relation or into the expression, I would be able to cancel out some of the terms. So this is what I would do. I know from trig again, this particular identity, if you have trig of say cos squared A plus sine squared A is equal to 1. Then similarly, if I had cos squared 2x plus sine squared 2x, it is equal to 1. So that's the idea I will be using. So I can say that is cos squared 2x is equal to 1 minus sine squared 2x. So I want to substitute cos squared 2x as 1 minus sine squared 2x into the expression. So I end up cos 4x is equal to 1 minus sine squared 2x minus sine squared 2x. I end up getting cos 4x is equal to 1 minus 2 sine squared 2x. So I substitute this expression, let me call it a, into the limit expression, this. So what was the limit expression? That was limit as x is approaching pi on 4 of, that is 1 minus sine 2x over 1 plus cosine 4x. And I know my cosine 4x now, which is 1 minus 2 sine squared 2x. So this is quite simple. So we have on the numerator 1 minus sine 2x. On the denominator we'll be having, that it is clear from here, we'll be having negative 2 sine squared 2x. Negative 2 sine squared 2x. So from here, I guess it is simple. Okay. Oh, I think I made a mistake. Oh, it's not supposed to be. I forgot to bring the 2. So because I have 1 plus 1, which is 2, so 2 minus 2 sine squared. So from here, the job is done. In the denominator, I can factorize out 2 to obtain 2 out 1 minus sine squared 2x. I can also factorize this expression, write it as difference of 2 squares. So I end up with coming. I have to be careful when undoing these because in the last lecture, I think I erased everything. So I had to start all over again. That was just by the way. Now, from here, for this expression, I can write it as a difference of 2 squares. So 1 squared minus sine squared 2x. There's nothing confusing about this. There's nothing confusing about this. Now, for the denominator, as I said, you can factorize, write this as 1 plus sine 2x multiplying 1 minus sine 2s. That is factorizing it as difference of 2 squares. Now you realize this cancels this. So we end up with limit as x approaches pi on 2 of 1 over that is 2 multiplying 1 plus sine 2x. So from here, it is so simple. So as x approaches pi on 2, what are we getting? We have 1 over 2 multiplying 1 plus, that is sine pi, because when pi on 2 is substituted into the expression here, 2 cancels out the 2 on the denominator. So we end up with 1 plus sine pi. So this is 1 over 2 multiplying 1. What is sine pi? What is sine pi? That is sine 180 is 0. So we end up getting half. So our answer is half. Yeah, so I believe this is quite understandable. Now let us solve one last question and I'll give you some assignments. Then we begin with what I want us to begin today. So last question is, that is that if you have the limit as x is approaching 1 of the expression x raised to the power 2 on 3 minus 2 raised to the power 1 over 3 plus 1 divided by x minus 1 all squared. Now, I told you this in the previous lecture. We have a cube root expression. So what do? They are all radical expressions. So you try as much as possible to do what? to rationalize our expression here so as to get rid of the what? Of the radical. But then we first check if this is an indeterminate. So doing our direct substitution, that is, we end up with 1 minus 1, sorry, 1 minus 2, yeah, because this is I think I didn't write it. This is supposed to be 2x raised to the power 1 over 3. Yeah, so 1 minus 2 plus 1 divided by, that is 1 minus 1 all square. So we end up getting 0 over 0, and this is clearly an indeterminate. So what do we do then? What do we do then? It is simple. So since we have a radical, we rationalize, or we can substitute in some expression such that when that expression is substituted in, the radical goes away. So I'll use that one instead. So let's say that is y cube be equal to x raised to the power 1 over 3. If y cube is equal to x raised to the power 1 over 3, no, not 1 over 3, but instead x, y cube is equal to x, because when I substitute y cube in place of x, that is, I'll cancel out the cube root. Now if y cube is equal to x, then as x approaches 1, then my y also approaches 1. So my new limit will be limit as x is approaching 1 of, that is, y cube raised to the power 2 and 3 minus 2 y cube raised to the power 1 over 3 plus 1, that is x minus 1 by x minus 1. X is y cube, so y cube minus 1 all squared. This is what I have. This is what I have. I think the job is done. The job is done basically. The job is done basically here because I can say let say let a be equal to let a be equal to y cube from here, and if a is y cube, then what will be my new limit as well? A will also approach 1, so I can say that is a approaching 1 of a okay, let me not do it like that. I think that one is a long process. Let me just effect the cubes. Now if I y cube raised to the power 2 thirds gives me y squared minus 2y plus 1 all on y cube minus 1 all squared. Now from here I can factorize out the numerator. Now y squared multiplied by 1, factors of y squared when more multiply will give you y squared, but then when added will give you negative 2y. They are, that is negative y and negative y. We have negative y and negative y plus 1 all on y cubed minus 1 all squared. So what do we have? That is y out y minus 1, negative 1 out y minus 1. So I have y cubed minus 1 all squared. You can also do it the method I was about to execute, but then that one, I think it would delay. So let me just use this and then we hurry up and then start what we are supposed to start today. So I've factorized the numerator to obtain y minus 1 all y minus 1 all squared, which is the same as y minus 1 multiplying y minus 1 in parentheses. Now, I have y minus 1 multiplying. The denominator can also be factorized. I can factor the denominator as y minus 1. I've already taught you this, so I'm writing it straight away. Y squared plus y plus 1 all squared. All squared. Let me just go to a fresh page. As I had limit as y was approaching 1 of y minus 1, then I had, that is y minus 1, y squared plus y plus 1 all squared. Was it squared or cubed? Let me check if it was cubed. Yeah, it was squared. It was it was squared. Okay, so yeah, so yeah, we can cancel out some of the terms. So y minus 1, let me write that squared, divided by y minus 1 squared, y squared plus y plus 1 squared. This can be written as the limit as y is approaching 1 of y minus 1 all squared divided by y minus 1 all squared, multiplying y squared plus y plus 1 all squared. So this cancels this. Then I now have the limit as y approaches 1 of 1 over y squared plus y plus 1 all squared. So here is simple, so you just have to do a direct substitution. So as y is approaching 1, what do we have? 1 over 1 plus 1 squared plus 1 plus 1 all squared. So 1 plus 1 plus 1 3. 3 squared is 9. So our answer is 1 over 9. Our answer is 1 over 9. Our answer is 1 over 9. So let me give you an assignment for you to try. Let me give you an assignment for you to try. Then we'll start with what we're supposed to start today. So assignment, try this. As limit as x approaches a of the expression root of a plus 2x minus root 3x all over, that is root of 3a plus x minus 2 root x. So show that this limit is equal to, that is 2 over a root a. State the value of a. So that is your assignment. So try and do the assignment. If you have the solution, you can send it to me to my WhatsApp line 0549528611. So you can send it to me here on my WhatsApp line if you have the solution. Now the first person to send me the solution will have a prize to win. So if you are the first person to send me the solution, you have a prize to win. All right, let's start today's work. So standard limit. I've already introduced you to some standard limits. I think I've already introduced you to some standard limits. I'll state some of them here. So I'll state some of them here for us to just revise over them. Yeah. But let me state some. Okay. Okay. So you remember this if you have the limit as x is approaching 0 of 1 minus cos x divided by x. This limit is equal to 0. So it's the first standard limit I'm stating. Now the second one I will be stating. Sorry. What is happening to my pen? So the limit as x approaches 0 of sine x on x is equal to 1. The limit as x approaches 0 of tan x divided by x is equal to 1. But you can actually show that this is equal to 1. So I'll give this to you as an assignment. Show that. So show. Let me know, right? Just write show. Show that tan x over x is equal to 1. If you know these two, just show that tan x over x is equal to 1. Now the fourth one I'll be given. That is, if you have the limit of a raised to the power x minus 1 divided by a is equal to the natural logarithm of a. Or you can say log to the base e of a. The fifth one, limit exponential of x minus 1 divided by x, that is as x is approaching 0 is equal to 1. The next one, limit as x approaches 0 of, that is log 1 plus x divided by x is equal to 1. Another one, if you have the limit x approaches 0 of 1 plus x raised to the power 1 over x is equal to exponential. Another one, the limit as x approaches infinity of 1 plus 1 over x raised to the power x is equal to exponential. So I think I think the limit rules are okay. Okay, let me add some more. Just in case I don't want to leave any student behind. Divided by x minus a, which is equal to a raised to the power n minus 1. This can be proven from L'Hopital's rule, but then we'll talk about L'Hopital's rule after we are a bit through with differentiation. Talk about L'Hopital's rule. You can prove this with L'Hopital's rule. Now the 10th one is the limit of sine inverse of x divided by x, which is equal to 1. 11. The limit as x approaches 0 of tan inverse of x over x, which is equal to 1. Yes, so I think these standard limits are okay. So for exam's sake, try as much as possible to memorize them. It is not good to be memorizing stuff, but then for these, for exam's sake, try to memorize them. Okay, let's move on. I want us to apply some of these limits in solving problems. I So I don't really know the questions to start with. For these, you have interesting questions under these. because and so some of the questions can also be very tough. That is, if you are really mastered them, you don't have any problem. Frankly speaking, if you've mastered them, you don't really have a problem. But then if you've not really mastered them, you would definitely find yourself wanting, and it is normal. It is normal for such problems. So we'll start with some. We'll start with some. Excuse me. So let us start with some of the problems. Let us start with some of the problems. Okay. Let's say you have. Let's say you have the limit as x approaches 0 of sine 5x divided by x. There's a simple one. There's a simple one, but then it will help you understand the concept very well. This in particular will help you understand the concept very well. So sine of 5x all on x. What would the answer be? Now, I can write this as that is limit as x approaches 0 of sine 5x divided by 5x, then multiply here to by 5, because I've multiplied the denominator by 5, then I would have to multiply the numerator by 5. Then I can apply the product rule of limit. So the limit of sine 5x divided by 5 times limit of what? The constant. Or there's no need for you to even do this, because it's a constant and it can move out of the limit sign. So what do we get? 5 multiplying. Now the limit of sine 5x over 5 as x approaching 0, what do you think it will be? Now, since we know that the limit as x is approaching 0 of sine x on x is equal to 1, then the limit, it makes sense to say that the limit as x is approaching 0 of, that is sine 5x over 5x, is also equal to 1. So all the time, think about it this way. The limit as x approaching 0 of, say, sine, let's say, box over box is equal to 1. So if you think about it this way, that is, it will be simple for you. So this is my box, this is my box. So sine 5x over 5x is equal to 1. Then I can say that, then I can say that the limit as x is approaching 0 of sine 5x over 5x times 5 is equal, since I know the limit of this is 1, is equal to, this shouldn't be x, shouldn't be any x, is equal to 5 times 1. So we have 5. So 5 is the answer. 5 is the answer. Now let's step it up a little bit. Let's step it up a little bit. Let's just say you have the limit as x is approaching 0 of log 1 plus 3x divided by log 1 minus 2x. Now we can also apply some of the limit rules here. You can apply this rule. Let me show you. Let me see if I'll see it. You can apply this rule. We can apply this rule in particular. You can apply rule 6. This particular rule. That is what we'll be applying. So oh, why is the question? I read the question somewhere. Okay, I think I would have to go up. Oh, I can't find my problem. Never mind. Let me just write it again. So the limit x approaching 0 of 1 plus 3x divided by log 1 minus 2x. There's one thing I can do. Now I know that the limit as x is approaching 0 of, oh, supposed to be log here, as x approaching 0 of log, that is 1 plus x divided by x is equal to 1. I know this. Then I can manipulate this such that some of the logarithmic expressions will look like this expression here to make my limit evaluation simple. To make my limit. So this is what I can do. I can say the limit as x approaches 0 of, say, so this is what I will do. Since I have 3x here and the standard the standard limit for this particular the standard limit I can use is this, then I want to manipulate this logarithmic expression for it to look like my standard. So I will divide by 3x and multiply here by 3x. Then I will bring in my log 1 minus 2x. So I know that the limit of this particular expression will be 1. So the limit as x is approaching 0 of, so I'm applying the product rule, over 3x times limit as x is approaching 0 of 3x over log 1 minus 2x. So this is 1. So I have 1 multiplying the limit. Let me just now write the 1 because 1 times anything is nothing. So the limit as x approaches 0 of log 1 minus 2x can also be written as, I can also manipulate this as well. I can say there's one thing I can do. There's one thing I can do. I can say that that is the limit as x approaches 0, because I want, this is what I want to do. I want this particular log expression, right? The limit of this log expression to look like the standard. The standard was limit as x is approaching 0 of log 1 plus x divided by x is equal to 1. So that's what I want to get for here. Now, if I reciprocate this, I'll also end up with the same 1. So I can do one thing. Then this is what I will do. 3x, I'll multiply the numerator by negative 2. Then the denominator by, no, not okay. I can multiply by negative 2. Then the denominator also by negative 2 to get log 1 minus 2x. Now, the limit as x approaches 0 of the expression, that is negative 2 divided by log 1 minus 2x, right, multiplying 3x over, okay, write the x here and erase this x. They're just you manipulating the expression according to the standard you are using. Yeah, so from here, I know that this limit gives me 1. this limit gives me 1. That's what I know. I know that this particular limit will give me 1. Here is supposed to be -2 because you have -2 here. So this limit will give me 1. Then I can say my -2 and 3, the limit as x is approaching 0 of 2x divided by log 1 minus 2x. So there's not anything for you to be confused. See, listen. So if you have, we already know that the limit as x approaches 0 of log, that is 1 plus x, all on x gives you 1. Then similarly, if you invert it, you're also going to get the same thing. So x on log 1 plus x will also be equal to 1. That is what I'm applying here. That is what I'm applying here. So yes, we'll end up with -3 on 2 times 1. So our answer is supposed to be -3 over 2. As simple as that. It is not difficult. Now let us try another one. Let us try another one. Now say we have the limit as x approaches 0 of exponential raised to the power sine x. No, not sine x. I mean exponential raised to the power x minus. That is exponential raised to the power sine x divided by x minus sine x. Now we can also apply standard limit to solve this. Now what do I do? Okay, this is my way of doing it. You can also devise a way of doing it. Now, there's one thing I would do. I would factorize the exponential raised to the power sine x, right? You will understand the reason why. So limit as x approaches 0 and factorizing exponential raised to the power sine x. What do I get? I get exponential raised to the power x divided by exponential raised to the power, exponential of sine x minus 1 all over x minus sine x. Now, the limit as x is approaching 0 of exponential of sine x. Now, the first thing can be written as exponential. Since they have the same basis, can write exponential raised to the power x minus sine x minus 1 all over x minus sine x. Now, I can say the limit, I can say the limit as x approaches 0, as x approaches 0 of exponential sine x multiplying and applying the product to limit as x approaches 0 of, that is exponential raised to the power x minus sine x minus 1 all on x minus sine x. Now the limit of this expression is familiar. You can compare it to this particular limit. That's x as x approaches 0 of exponential of x minus 1 all on x. So this can be compared to this. Now in place of x, we'll put in there x minus sine x, right? And this limit, I already know that it is equal to what? It is equal to 1. So I can say that the limit as x approaches 0 of exponential raised to the power sine x multiplying 1. So we end up with the limit as x approaches 0 of exponential sine x. But as x approaches 0, what will the limit be? The limit will be exponential raised to the power sine 0. And sine 0 is 0. Then I can say exponential raised to the power 0, just 1. So the answer for this limit is 1. The answer for this limit is 1. This is an interesting one. This is quite interesting. Now, let us try another one. Let us try another one. Let me see. Will this be difficult? Will this waste time? If we waste time, let's pray it doesn't waste time. So the limit of exponential raised to the power 3 plus x minus sine x minus exponential of 3 all on x. Now we have to evaluate this limit as well. What would the answer be? What would the answer be? Now we can also apply some of the limits rules here. It is simple. I mean the standard limit. You can apply some here. Now for here I can factorize. Okay, this can be written as right. Then I can rewrite this as the limit as x is approaching 0 of exponential of 3 exponential of x minus exponential of 3 and it's exponential of 3 minus sine x all on x. Then the limit as x approaches 0 can factorize out e raised to the power 3. The e to the power 3 bracket open e to the power x minus 1 bracket close minus sine x all over x all over x. So we have separated this. What can I do? What can I do? I can, that is limit as x approaches 0 of exponential raised to the power 3 exponential raised to the power x minus 1 all on x minus limit as x approaches 0 of sine x over x. So you can clearly see that from here we can apply some of the limits, some of the standard limits. One of the standard limits can apply this. That's the limit of this expression as x approaches 0 is equal to 1. We can apply it here. We can also apply another standard limit here. We can apply this one as the limit as x is approaching 0 of sine x divided by x is equal to 1. So let us apply. So we can say that exponential raised to the power 3 is out. It's a constant. The limit as x approaches 0 of exponential of x minus 1 divided by x minus the limit as x approaches 0 of sine x over x. So this limit is 1. So exponential is about 3 times 1 minus 1. This limit is also 1. So I end up with this. Yeah. Let us solve the last question, then we call it a day. I don't know if will it be the last 2 questions or the last question. I don't know. Let us try this question. The limit as x approaches 0 of 15 raised to the power x minus 5 raised to the power x minus 3 raised to the power x plus 1 divided by x squared. Now this is also very simple. Right? This is also very simple. I can separate the 15 raised to the power x. I can rewrite it as that is 3 raised to the power x multiplying 5 raised to the power x minus 5x minus 3 raised to the power x plus 1 all on x squared. Okay, let me go to the next page. So the limit as x approaches 0 of 3 raised to the power x 5 raised to the power x minus 5 raised to the power x minus 3 raised to the power x plus 1 all on x squared. Then I can rewrite this as, because I can factorize from considering this term and this term. I can perform some factorization because the common term over there is 5 to the power x bracket open 3 raised to the power x minus 1 minus 1. I get 3 raised to the power x minus x all on x squared. For this term, there's a common, this term and this term have a common term, so I can factorize that common term out. So the limit as x approaches 0 of 5 raised to the power x minus 1, 3 raised to the power x minus 1, all on x squared. Can we write this as the limit as x is approaching 0 of 5 raised to the power x divided by x times 3 raised to the power x minus x divided by x. Then I can apply the product rule and say the limit as x approaches 0 of 5 raised to the power x minus 1 divided by x multiplying the limit as x approaches 0 of 3 raised to the power x minus 1 on x. Then from here we already know, if you could remember, one of the standard was the limit as x is approaching 0 of, say, a raised to the power x minus 1 over x is equal to natural logarithm of a, or log to the base e of a. You remember this? So I can say the limit as x approaches 0 of 5 raised to the power x minus 1 on x is equal to natural logarithm of 5. Similarly, the limit as x approaches 0 of 3x minus 1 divided by x is equal to natural logarithm of 3. And since these limit expressions are multiplying, then I end up with ln 5 multiplying ln 3. Simple. Now let us do one last question. Now say solve for p plus q. So the limit as x is approaching 0 of p exponential raised to the power x minus q all over 2x is equal to 1. You have to find the value of p and q, then find the sum of those two values. Yeah, so time is fast spent. I'll leave this for you as an assignment. But let me give you a clue. Let me give you the answers. Try Okay, you know what? I won't give you the answer. If you are the first person to send me the solution, you'll get a prize. 054. That's my contact. 9528611. Can send it to me on WhatsApp. Then I'll send you the prize over. So you have to solve for p plus q if the limit of this is equal to 1. Okay, so I'll end the lectures here. Have a wonderful evening.